बस ये स्टार्ट करें। अच्छा क्या समर 20 एंड 2-2 ठीक है। उसके कुछ क्वेश्चंस रह गए थे लास्ट वाले के। ट्राई एंड 7 क्वेश्चंस ठीक है। ट्राई एंड डू दैट ऑन योर ओन ठीक है। अच्छा स्टार्टिंग विद दिस वन ये द फर्स्ट। अच्छा व्हाट इज द डेफिनेशन ऑफ रिलेटिव एटॉमिक मास? क्या डेफिनेशन होती है?
It is the average mass of an atom that is compared to the relative mass of carbon-12.
One
ठीक है।
twelfth.
ठीक है और रिमेंबर एवरेज।
112.
ठीक है। एवरेज मास ऑफ एन एटम ओके कंपेयर टू
One
1
twelfth.
1/12 द मास ऑफ।
An atom of carbon 12.
ठीक है। या कार्बन 12 आइसोटोप ठीक है।
Hmm.
अच्छा नेक्स्ट वन कैलकुलेट द रिलेटिव मास ऑफ गैलियम इन दिस सैंपल गिव यू आंसर टू फोर सिग्निफिकेंट फिगर्स। तो क्या फॉर्मूला होता है फॉर रिलेटिव एटॉमिक मास? well this is given so
Hmm.
what do you do?
हम परसेंटेज को मल्टीप्लाई करते हैं मैथ से
ठीक है सर
और
ठीक है 69 मल्टीप्लाइड बाय 60.11%।
प्लस 71 मल्टीप्लाई बाय 39।
Divide by 100.
ठीक है और डिवाइड बाय 100 इसको कैलकुलेट करो ना कि what do you get? मुझे
दो
तो
सेकंड कैलकुलेटर लेके आ।
अच्छा मेक श्योर इसको व्हेन यू प्रैक्टिसिंग इवन ना तो ट्राई एंड डू द कैलकुलेशन ठीक है। क्योंकि पेपर के अंदर इट्स वेरी इंपॉर्टेंट कि वो कैलकुलेटर के ऊपर ना आपका जो स्पीड है ना दैट इज गुड। क्योंकि टाइम इज समथिंग दैट यू वुड हैव टू सेव so you have to be quick with the calculator as well।
दो सेकंड 69 into 60.11 plus 71 into 39.89 divided by 100 um 69.8 हो जाएगा थ्री सिंगल फिगर्स में।
ठीक है 69.8 ठीक है that's your yeah। अच्छा नेक्स्ट इज कंप्लीट द टेबल व्हिच डिस्क्राइब्स द gaseous atom of gallium। तो मतलब 71 है तो वो इसके लिए वो चाहिए। यू नीड द डेटा बुकलेट।
हम्म,
तो 1 second where's the data booklet? ये रही। तो उसका क्या प्रोटोन नंबर you can find it over here कि gallium is 31।
31 तो ये 71 माइनस 30
अच्छा तो न्यूक्लियन।
और न्यूक्लियन तो वो होगा
अच्छा
70।
न्यूक्लियर नंबर तो 71 ही है तो
हाँ।
31 तो उसका प्रोटॉन नंबर था।
हम्म।
टोटल नंबर ऑफ इलेक्ट्रॉन्स इन द लोएस्ट एनर्जी लेवल क्या है?
2।
हाँ टू होंगे फर्स्ट शेल ठीक है 1s2। So there are two electrons. Type of orbital which contains the electron in the highest energy level.
थर्टी
Remember,
वन तो ये
ये
Which
मैंने
group
कहा
is
कि
it in?
it's in ये
3.
ग्रुप 3 तो
3.
क्या outermost shell? What is the outermost shell?
3.
नहीं नहीं
इसके नंबर ऑफ
orbit
इलेक्ट्रॉन्स टाइप ऑफ ऑर्बिटल।
Orbital,
what
that
is
would
the
be D. No, P. P, P, P.
ठीक है मैंने ये याद रखना कि this first one is S1, this is S2 तो ये क्या होगा this is S2P1।
Yeah.
हाँ से
ठीक है
स्टेपन
सो
ठीक है।
अब है P2 P3 P4 ठीक है
हम्म,
so the orbital which contains the electron in the highest energy level that's P।
बस भी ठीक होगा।
ठीक है। When gallium is heated in excess of chlorine, gallium chloride is made. Draw the shape of gallium। क्या एंगल्स होंगे? Gallium is in group 3।
तो ये ट्रायगोनल प्लेन है
ठीक है
120।
क्योंकि कोई लोन पेयर्स नहीं होंगे it's just three bonds because it just has three electrons and all of them are bonded तो bond angle shape of molecule तो ये होगी ठीक है that's what you're going to draw। और bond angle क्या होगा?
120 डिग्रीज।
ठीक है that's going to be 120 degrees। अच्छा गैलियम ऑक्साइड एंड एल्यूमिनियम ऑक्साइड रिएक्ट इन द सेम है जब वो ये कहता है ना बेसिकली टॉकिंग अबाउट एल्यूमिनियम ऑक्साइड एंड इट्स ये वो इनऑर्गेनिक का क्वेश्चन है। सो राइट एन इक्वेशन ऑफ गैलियम ऑक्साइड विद HCl। एम्फोटेरिक होता है ना Al2O3।
Mm-hmm.
तो क्या होगा व्हाट इज गोइंग टू बी फॉर्म्ड?
I think gallium. Wait. Um, is it gallium chloride
ठीक है, it
or
is going to be
hydroxide? Oh, gallium chloride.
chloride plus water, right?
Yeah,
Or with NaOH क्या होगा? What is going to be formed?
I think it will form sodium. I don't know. I did this today. I can't remember. Sodium NaGaOH. NaGaOH, is it?
हाँ, NaGaOH4.
OH4, yes.
और या फिर you could
Plus
also
H2.
write sodium eliminate क्या होता है? Na2N2 NaLO2 as well. Sorry, you can instead of Al you can have G. But I'll show you where this is written. ठीक है, it's in the inorganic notes. Yes, ये वाले. तो just remember कि कहाँ पे acid base behavior. So aluminum oxide was the one that was amphoteric. So it would react with HCl. It would also react with hot concentrated NaOH as well. तो उसमें it will form sodium aluminate. ठीक है. So or you can instead of O you can have OH. ठीक है. तो ये इसका आंसर. अच्छा, next one is ये clear है?
Yeah.
ये basic memorization है. ठीक है. You have to memorize the inorganic notes. अच्छा, फिर you have nitric acid can be made in a three-stage process. Ammonia is oxidized by oxygen from the air to form nitrogen oxide and water. This तो वो क्या reaction of equation shows. क्या होगी? What is the equation in stage 1?
Ammonia is oxidized. So ammonia plus
क्या?
oxygen,
ठीक है, that's O2.
And
which will give you nitrogen. NO2. NO. Sorry.
NO plus H2.
ठीक है, you have to balance.
Yeah.
अच्छा ठीक है, you just have to balance it. तो क्या होगा? मतलब
I think it's balanced. Is it? No. There are 3 H.
2 NH3 करते हैं, उससे 6 हो जाएंगे उधर. And then
and 3H2.
3H2, and then 2
and NO.
नहीं, फिर वो N. अच्छा, remember कि always try to balance the easiest first. ठीक है, the one that appears in 2 places. Oxygen को end पे छोड़ देना. ठीक है, oxygen is in 3 places. So it's going to be a lot harder to balance oxygen. ठीक है, तो N और H पे focus करो. First try and balance N and H. तो N is not balanced. There are 2 N's, so there should be 2.
2 there.
अब oxygen पे आ जाओ last. ठीक है, when N and H are done, तो फिर oxygen. ठीक है, oxygen
just put 3 there.
5/2.
Oh, it's 5. Okay.
5/2 होगा ना. ठीक है, so that's it.
ठीक होगा 5/2.
Ammonia का dot and cross. ठीक है, that's kind of easy. There's N and 3 H's. Or how many electrons of N are left? It's in group 5.
2 रह जाएंगे.
ठीक है, so it's going to have a lone pair. ठीक है. So out of 5, only 3 are bonding. So next one is in the boxes give the oxidation number. What's the oxidation number of N in NO2?
Minus
what?
2.
नहीं, मतलब NO2 है ना, so
NO2. Oh, okay, nitrogen. What are they asking about? The oxidation of complete nitrogen oxide or just nitrogen?
Just nitrogen.
Oh, okay, nitrogen.
So oxygen is minus 2 times 2, right?
Yeah.
Minus 4.
Plus 4.
Plus 4.
Plus 4.
Oxygen minus 4 है ना, तो nitrogen plus 4.
अच्छा, HNO3 में क्या होगा? What's HNO3? What's N in HNO3?
H will be X, or will it be plus?
H is always plus 1.
Okay.
N would be
plus 5.
X.
हाँ, ठीक है, minus 2 times 3 and that's equal to 0. X will come out to be plus 5.
Yeah.
इसमें plus 2.
ठीक है, that's plus 2.
Plus 2.
Explain why the reaction is described. What's a disproportionation reaction?
Where both oxidation and reduction takes place.
Where the same element gets oxidized and reduced.
Yeah. Oh yeah.
ठीक है, so this is getting oxidized, N is getting oxidized, and N is this one that's getting reduced as well. ठीक है. तो आपने mention करना है कि N, I mean, that's what you're going to write. N is getting oxidized, and you can show that it goes from NO2 to, it goes from +4 to +5, and the same N is also getting reduced, and it goes from +4 to +2, ठीक है? अच्छा, फिर the release of nitrogen monoxide into the atmosphere causes atmospheric pollution. State and explain the effect of moist air. तो nitrogen monoxide gas in contact with moist air, क्या होगा?
I think it's gonna.
नाइट्रोजन डाइऑक्साइड या क्या होगा?
मतलब क्या होगा moist air के साथ N?
Will it form acidic rain?
ये मैं वैसे एक इसका मैं वैसे देख लेता हूँ कि क्योंकि एक one pollutant has been added in your course, ठीक है? That's PAN, peroxyacetyl nitrile, ठीक है? इसका एक second, let me show you the marking just to confirm. Yeah, actually, nitrogen dioxide. मैंने वही confirm करना है, is it acid rain or is he talking about
नाइट्रोजन डाइऑक्साइड
peroxyacetyl nitrile? एक second. कौन सा वाला था? ये सब तो कर लिया. This one, ये वाला. Acid rain ही है ना? हाँ ठीक है. He's talking about acid rain. Peroxyacetyl nitrile जो है ना, that's वो smog के अंदर होता है, ठीक है? PAN. तो that's a different pollutant. बस वो मैंने clear करना था. तो इसमें बस
So
वही
it's
होगा.
gonna
हाँ, so basically
form
what happens?
acid rain?
What happens is NO is going to get first oxidized, and it will form NO2. अच्छा, remember NO जो है ना, that does not react with rain.
NO
Yeah.
और फिर वो जो NO2 है ना, that
एसिड रेन और फिर नाइट्रिक एसिड बन जाता है.
हाँ, और उसमें मतलब एक you have to add in oxygen.
HNO3.
तो
ठीक
it
होगा.
forms HNO3, ठीक है? अच्छा, लेकिन वो याद रखा कि that's something separate. लेकिन PAN क्या, peroxyacetyl nitrile ना, इसमें जो नाइट्रोजन के ऑक्साइड्स होते हैं ना, नाइट्रोजन ऑक्साइड्स एंड स्मॉग, ठीक है? फोटो के जो स्मॉग होता है, दैट्स बेसिकली ये उसके अंदर ना PAN होता है, दैट्स अ पोल्यूटेंट दैट कॉज ब्रीथिंग प्रॉब्लम्स. ये एक पोल्यूटेंट है व्हिच हैज बीन एडेड, ठीक है? peroxyacetyl nitrile, बट रिमेंबर दैट सेपरेटली, ठीक है? इस वाले क्वेश्चन का उससे ताल्लुक नहीं था. As the next one, it's moles. Nitric acid made in stage 3 can then be reacted with ammonia to form this. You got an equation. Calculate the volume of nitrogen dioxide measured at room temperature and pressure required to make 40 tons of ammonium nitrate. So you need 40.
I think we're gonna use the nitric acid from the first reaction, and then I think link it with the second reaction to get like mole ratio and then do it. Is that it?
Okay, basically you have to find, he's asking for the mass of this thing, right? The volume of this thing, right? He's asking for the volume, but you have to start over here because this is 40 tons. This is the information that's given. Instead of doing all the conversion, I can, since it's kind of working show करनी है, so it's important that you do the conversion. So how many grams do you have? That's 40 tons. Million of
1 million.
1 million grams, right? So how many moles? What's the amount of NH4NO3?
NH4NO3. Can we get the
N क्या था? 14. 14.
Can we get the periodic table?
Okay, I mean you can just download one.
N14 है और O16 है और H1
है, H1 है.
80 आ रहा है मेरा.
ठीक है, 80 है. So how many moles you got?
Yeah, 80.
हाँ, 80. तो ये 500,000 हो जाएंगे.
500,000?
हाँ, 500,000 हो जाएंगे.
Yeah, 500,000.
So you get these many moles. So how many moles of NO2 do you need for that?
I think we're gonna link it. Like let's find the mole of HNO3 here. Yeah.
Which is going to be exactly the same.
Yeah. So we can just do 3:2. Is that 2 up in there in the equation?
लेकिन this would be 500,000 moles as well, ठीक है?
Mm-hmm.
Maybe for
तो ऊपर भी it's going to be 500,000.
Yeah. So we can do 3:2.
हाँ ठीक है.
अच्छा सही है क्योंकि वो उसका जो प्रोडक्ट है उसका रिएक्टेंट है.
हाँ तो remember
हाँ.
ये रेशियो जो है ना, एक चीज याद रखना कि the ratio of one equation has nothing to do with the ratio of the other equation, ठीक है?
सही हो गया, सही हो
Mhm.
गया.
वो जितना भी नाइट्रिक एसिड वहां से है ना, that all got used up over here, so they have the same moles, ठीक है?
ठीक हो गया. एंड देन इधर बेसिकली
इधर रेशियो है 2:3.
हाँ तो
ये कितना हो गया?
3:2.
तो ये
So what's going to be this?
2 सेकंड. ये
Okay.
500,000 डिवाइड बाय 2 into 3 कर लिया अगर हम तो 750,000.
ठीक है
750,000.
1050,000. उसका वॉल्यूम निकाल लो.
अच्छा 750,000 moles और फिर
How do you find volume? It's और कितने में निकाल? नहीं, he didn't ask for the unit, so we just do T cube.
Times,
Or-
yeah.
room and make sure it's room temperature. Otherwise, you have to use PV equal NRT. ठीक है? तो
Uh-huh.
तो क्या है आंसर?
I got it completely.
Eight,
What did you get?
18 into 10 is to power 6. मतलब it was like मैं स्टैंडर्ड फॉर्म में
Okay,
कर
I
लिया.
got 1,800,000.
हाँ
No,
वही है.
18 million. 18 million. I got 18 million.
Yeah,
that's
mine is the same. Mine is the same. वही है.
10 plus 6 is a million. ठीक है?
Hmm.
अच्छा, ammonium nitrate, where is it used?
Fertilizer.
No. Is
Fertilizer.
it?
But nitrates.
Okay.
Remember plants use
Okay, yeah.
use NPK salts. So
NPK, yes.
nitrates, ammonium, phosphate, salts,
Yeah.
potassium, aja, that's all these salts, they are fertilizers.
Potassium. Yeah.
As the next one, organic state, a name for the type of reaction.
Which reaction?
Hydrolysis.
Hydrolysis.
Okay, so this is hydrolysis. So explain in detail why glucose and fructose are a pair of structural isomer. Your answer should refer specifically to those two molecules. Basically, what's a structural isomer? Why are they structural isomers?
Structural isomer, they have the same structure but different functional group. I mean, like the position of the functional group is different.
Position of function.
No, structural isomer is they have the same molecular formula.
But different structural formula.
Different structural formula.
और इन दो molecules में
but in the specific but different structural formula. Why do they have different structural formulas? Because
the position of the
functional group.
Is there
CH2OH हुआ उधर like top right.
Yeah, they changed the position. वो वहाँ पे ऊपर और नीचे है. Like in glucose, वो नीचे है और fructose में ऊपर है.
हाँ बस ठीक है. नहीं वो it's not मेरे ख्याल से इसका
ये branch isomer है. मेरे ख्याल से branch isomer है.
ये branch isomer नहीं है क्योंकि carbon chain is the same. वो 5 carbon atoms in a line. This is 5 carbon atoms in a line. It's branch isomer. It's a functional group isomer क्योंकि you can call it.
तो इसमें chain ही है.
इसमें
isn't it chained?
नहीं, it's got 6 ना. ये 6 यहाँ पे भी है, 6 यहाँ पे भी है.
अच्छा वो एक ही chain है. हाँ सही है. सही वो मैं confused हो गया.
Okay.
अच्छा तो it's not a chain isomer. It's a functional group isomer क्योंकि one of them is a this is an aldehyde.
अच्छा that's a ketone. सही है.
Oh, makes sense. It makes
ठीक है.
sense.
लेकिन मेरा भी ख्याल इसका वो देख लेते हैं कि इसके अंदर he just wanted this. ठीक है. इसका देख लेते हैं कि both have the same molecular formula. अच्छा वो detail दे देते हैं कि this is the molecular formula. And any idea that glucose and fructose, they're the same number and same type of atoms, but are arranged in a different. मतलब हमने कह दिया था ना, they have a different.
हाँ, once the carbon at the end.
Carbonyl group.
ठीक हो गया.
Yeah.
तो जो ठीक है वो मेरे ख्याल से बताना था. वो middle of the chain है, वो उसके एक end पे chain है.
ठीक हो गया.
One is an aldehyde, the other one is a ketone. That would have been some idea.
I always get confused between which one is a ketone and which one is an aldehyde because like ketone is a more complex one.
The ketone is the one where the carbonyl is in the middle of the chain.
Okay.
Aldehyde is the one where the carbonyl is at the end of the chain. ठीक है?
Okay.
अच्छा अगला reaction A occurs faster in the presence of an enzyme. This is because this is reaction B. The activation energy for reaction B is 29 kilojoules per mole. Predicted value for the activation energy of reaction A.
लोअर होगी तो
नहीं reaction A की lower होगी या higher होगी? Reaction B is the one
और रिएक्शन
with the enzyme.
I think it will
Oh,
be
अच्छा,
higher
okay,
because
okay.
it
It's
occurs
higher,
at
it's
a
higher, it's
faster
higher.
rate.
सही है. Reaction A occurs faster in the presence of an enzyme, and this is reaction B. तो मतलब B is with enzyme, और फिर A में it's going to be higher.
So A would be the one that is slower, ठीक है? So
हाँ,
we
तो
have a
like
higher at 40 कर लेते हैं. कि
ठीक
मेरे
है.
ख्याल से कोई गाइडलाइन तो उससे दी नहीं है कि क्या होगी. So
हाँ,
Is there a range? कोई range है
I
मतलब
don't
इस range से
I
लेकर
don't
इस तक?
I don't think they I mean well they didn't give you anything any information to even determine the range. So
Okay.
value of fact second value of the
that are more
that are
बस
more than 29 but that's it ठीक है वो
वो 30 भी हो जाए तो नंबर
हाँ तो उससे रेंज कोई नहीं दी हुई ठीक है क्योंकि वही there's not enough
Okay.
information to figure out a range. As an enthalpy change for reaction A is -14. Predicted value for the enthalpy change for reaction B.
I think it will be higher, like minus 20 or something.
B जो है with enzyme है.
It's same है.
Same. Why?
Catalyst does not affect the
Enthalpy.
Oh yes, it does not take part.
The catalyst does not affect the overall energy change. It only makes the reaction easier. So it only affects
Faster.
the
Yeah.
Okay. So it's going to be the same. Also got relevant values. So we have the values it's -14. So it's an exothermic reaction, right?
Mm-hmm.
So that's your reactants.
Reactants and products.
Okay, that's a graph for exothermic. So the label we color. This is -14. Or so what was the activation energy? I think it was +29, right?
29.
So वो 29 थी make sure you write the units. And this is your activation energy and that's your delta H, ठीक है? Clear?
जी.
अच्छा अगला part 1 gram of sucrose is completely combusted. The heat energy produced is used. So he's burning कितना gram है? 1 gram sucrose.
Yeah, like the atom burns in oxygen.
But it's burning it, ठीक है? So heat energy produced increases. So there's 250 grams of water. ठीक है? और उसका temperature, what's delta T? How much? कितना delta T है? 25 to 15.7?
Yep.
अच्छा पहले तो enthalpy change of
15.7.
What's the definition?
That's what I said. When an element burns in oxygen to form
when 1 mole
1 mole of something is formed. I think 1 mole of something is burned in oxygen or 1 mole of something is formed.
when 1 mole of a substance burns completely मतलब in oxygen.
मेरी crash कर गया. Just one second. I say enthalpy change of combustion. It's the energy that is the energy released when 1 mole of a substance
is completely burnt in oxygen.
Burnt in oxygen.
Substance is completely burned in oxygen. In excess oxygen.
Can it be a compound?
हाँ, substance में सारा आ जाता है. It could be an element or a compound. It could be anything.
Okay.
Excess O2 and measured under standard conditions. क्योंकि वो अच्छा standard लिखने की जरूरत नहीं है क्योंकि he didn't ask for standard enthalpy change of combustion. So that's it. If he was talking about standard enthalpy change, तो फिर वो लिख देते कि end में कि it's measured under standard conditions. अच्छा, anyways, use the data booklet to calculate the enthalpy change for the combustion. अच्छा, इसका where's the information? This is the information. So what is?
I think this will be MC delta T.
So MC delta T, what's the mass of water that's used? That's 250 grams.
250. Yeah.
What is C of water?
4.18.
ठीक है, that's 4.18 और delta T जो है ना that's already 15 point
Your answer is 16,406.5.
16,000 कितना है? 400
406.5 joules.
अच्छा, but so that's the energy released minus sign होगा because the temperature is rising, ठीक है? So whenever you see temperature rising, that means it's exothermic, ठीक है?
Okay.
अच्छा, so minus sign होगा. But this is not the enthalpy change of combustion. What is this? And how do you?
You'll divide by 1,000 to.
Sir, मतलब that will just give you kilojoules. I'm just saying that this is not the enthalpy change of combustion of sucrose. How do you find that?
Okay.
ये for mixture
नहीं ये कितने moles के लिए? This is for 1 gram of sucrose.
अच्छा
Enthalpy
this
change
is
of combustion is
Oh,
for.
I get. You will do 1 mole of this will give you this much. Then how many moles will give us?
हाँ तो
Is that
Riksha
it?
method
1 gram में कितने moles होते हैं? It's calculate the MR.
Okay, yeah. That's 12 plus 22 plus 11 times 60. I think that's 210.
नहीं, it's going to be
No. It's not. It's
342
more than that.
342
342 है.
I think so 342
तो 342 कितने moles हो गए?
1 over 342 हो गया that's 2.92 into 10 raised to power minus 3 3 single figures में करो
अच्छा ठीक है, -3 moles. तो निकालो कि 1 mole का क्या होगा? ये basically it's the formula is that it's MC delta T divided by the moles. So you'll
0.5 divided by 2.92
वो एक दफा divide by 1000 भी कर लो, so you get the answer in kilojoules.
हाँ फिर डिवाइड बाय 1000 कर लेते हैं हाँ तो 5618.7 kilojoules per mole
कितना?
5618.7 2 सेकंड
561 क्या था?
8.7 2 सेकंड में
56 वो देख लेते हैं, ये भी क्रैश कर गया एक सेकंड. 5618.7 56
10.
वो उन्होंने 4 सिग्निफिकेंट फिगर्स वाला किया हुआ है आगे -56111 बल्कि
नहीं तभी 18 मैं वैसे क्या वो थोड़ा सा डिफरेंस क्यों आया?
मैंने
ये
उस 1/342 को बहुत कम प्रिसिजन पे ले लिया होगा शायद
चलो हाँ ठीक है, आई गेस वो क्योंकि यू राउंडेड दिस ऑफ राइट,
हाँ आई राउंडेड दिस ऑफ 1/342
तो फिर वो
मैं
राउंडिंग एरर आ गया, ठीक है. सो
हाँ
अच्छा मेक श्योर डू वन थिंग, ठीक है.
मैं तो कैलकुलेटर्स की वैल्यू इस्तेमाल करता
हाँ
हूँ
मेक श्योर कि वो जो बीच में स्टेप्स है ना,
हम्म
इफ देयर इज स्टेप 1 और फिर देयर इज अ स्टेप 2 और फिर देन देयर इज द फाइनल स्टेप, ठीक है, स्टेप 3. तो बीच में ना मेक श्योर यू डोंट डू राउंडिंग, ठीक है. व्हाट वो जो भी कैलकुलेटर वैल्यू दे रहा है ना, ट्राई एंड यूज दैट, ठीक है.
हम्म
तो एंड पे जाके ना मेक श्योर यू डू द राउंडिंग एट द एंड, वरना वो फिर देयर इज गोइंग टू बी अ लॉट ऑफ राउंडिंग एरर, ठीक है.
हम्म
तो चलो ठीक है, वी गॉट दिस आंसर. और ये क्लियर है ना कि बीच में राउंडिंग कोशिश करना कि डोंट डू अ लॉट ऑफ राउंडिंग, ठीक.
हम्म
अच्छा, question number 4. An unlabeled bottle contains a straight chain halogenoalkane. So it's a straight chain halogenoalkane. The molecular formula of Q is C5H11X, where X is a halogen of. It's a straight chain. It's a 5 carbon atom.
straight chain
अब उसमें ना you got 3 possible isomers, क्योंकि वो जो X है ना, the halogen, it could either be on the first
It's
one, or
bromine.
second one, or the third one. अच्छा, bromine
It's
किसका मतलब?
bromine
हाँ
because
वो
a cream precipitate is observed.
Yeah, so that's bromine. Yellow is for iodine and white is for.
Iodine, chlorine,
क्लोरीन
हाँ ये रिएक्शन कौन सा हो रहा है जो यहाँ पे
chlorination.
नहीं
Is it?
नहीं what is the ionic equation of the reaction which forms?
Oh, silver nitrate. That's for test or.
ये जी 2 सेकंड
Wait, what?
NaOH में ऐड हो रहा है and then
But I think reaction here. What's the reaction?
Silver nitrate
Ag
plus.
plus OH minus.
नहीं बस वो होता है Ag+1 और Br-1 they combine and they form.
अच्छा सही है वो वाला Ag plus और
AgBr.
AgBr.
Oh, okay.
ठीक है, that's the solid precipitate that forms. That's just the ionic equation. ठीक है.
Okay.
Yeah.
And it's kind of
Bromine
further.
water.
अच्छा, what is the further test? Silver nitrate के apart from silver nitrate, it is followed by another test. Once you get the precipitate, ठीक है, this
Bromine water?
नहीं ये halides का test क्या होता है? Like the complete test.
Is it
I
not?
mean, you get the precipitate, then there's another step up. You add.
I have no idea.
You add ammonia.
और उससे क्या
Oh, yeah.
So
It
you
will either dissolve excess or no reaction, is it?
हाँ मतलब ये मैं खोल देता हूँ cream precipitate dissolves.
अच्छा
उसमें वो था ना कि if you have three precipitates, Cl-1, Br-1, I-1, ठीक है. Silver nitrate डालो तो the first one gives you a white precipitate. Br-1 gives you a cream precipitate. I-1 gives you a yellow precipitate. ठीक है.
ये कौन से उसमें है चैप्टर में?
ये इसी में जो नोट्स मैंने दिए मैंने एक सेकंड. ये कौन से नोट्स है ये वाला?
ऑर्गेनिक वाला?
हाँ इसमें हैलोजेनो एल्केन्स वाला पार्ट खोलो ना इसमें एक सेकंड. 1 second. ये आएगा. अच्छा पेज 21 पे डायरेक्ट चले जाते हैं. अच्छा हैलोजेनो एल्केन्स 1 second किधर गया? ये पता नहीं क्यों क्रैश की जा रहा है चीज. हाँ ये हैलोजेनो एल्केन्स और हैलोजेनो एल्केन्स में ना जहाँ पे रिएक्टिविटी ये टेस्ट है. आइडेंटिफिकेशन ऑफ हैलोजेनो एल्केन्स, हैलोजन इन हैलोजेनो एल्केन्स. तो वो इन सारों का जो टेस्ट है दैट्स वाइट प्रेसिपिटेट, ग्रीन प्रेसिपिटेट, येलो प्रेसिपिटेट. और फिर उस पर फर्दर टेस्ट हुआ दैट्स हु डिसॉल्व्स इन अमोनिया. दैट्स द फर्स्ट वन वाइट प्रेसिपिटेट जो AgCl का है ना, दैट इज वेरी सॉल्युबल इन अमोनिया. ब्रोमाइड का जो प्रेसिपिटेट है ना दैट इज ओनली सॉल्युबल इन कांस्टेंट या पार्शली सॉल्युबल, ठीक है, in concentrated ammonia. And the yellow precipitate of iodide, it does not dissolve. ठीक है, क्लियर है?
Okay. Yeah.
अच्छा फिर ये कि hold on a second. अच्छा next is we did that reaction Q with NaOH tends to produce to proceed by an SN2 mechanism. Suggest the structural formula of the straight chain halogen. अच्छा अब मुझे बताओ कि if it's an SN2 mechanism, is it a primary halogenoalkane or is it a tertiary or a secondary halogenoalkane?
SN2, I think tertiary is used.
SN2?
SN दो सेकंड.
No, SN1 tertiary is used. SN2 is primary and secondary.
चलिए मैं इधर शो कर देता हूँ कि where's the SN1, SN2. So for primary, the substitution happens in one step, ठीक है, SN2 mechanism for primary. The primary where the Cl would be at the or the halide would be at the end of the chain, ठीक है. तो वो OH या जो भी it's going to just knock out the Cl in one go. SN1 जो होता है that's for tertiary. So the Cl is somewhere in the middle of the chain, ठीक है, surrounded by carbon chains. Okay, a carbocation first gets formed, Cl gets knocked out, and then the nucleophile attaches, ठीक है. इसका मतलब है कि जो हमारी ऑप्शंस थे ना कि वो किधर मैंने बनाया था कि it was a 5 carbon atom halogen किस पे attached था? On which one would the bromine be attached?
Last
one. It's going to be a primary, ठीक है. क्योंकि कहीं और अटैच होगा ना तो it's going to be a secondary.
Secondary होगा तो सही है.
ठीक है, so मतलब you can put in the H's yourself. Explain why the reaction tends to proceed by an SN2 mechanism. उसकी justification क्या थी? Why do you have SN2 mechanism and not an SN1 mechanism? Why does it not?
एंड पे है चेन की तो इसकी वजह से वो डायरेक्टली उसको अटैक कर लेता है न्यूक्लियोफाइल.
because it will form an intermediate.
नहीं,
in
reaction is
SN1, SN2, sorry.
नहीं, why is the reaction proceeding? इसकी एक लाइन का आंसर है,
हम्म
बट अभी फिर समझ लो कि वो इधर नीचे लिखा हुआ है वैसे, why do primary, ये लिखा हुआ आंसर, ठीक है,
हम्म
बट रिमेंबर कि in an SN2 mechanism, in a primary halogen a carbocation is not formed, ठीक
हम्म
है, और रीजन ये है कि it has a very unstable carbocation. प्राइमरी के अंदर ना, if you have a primary and, और उसकी एक्सप्लेनेशन ये है कि if you have a primary halogen, if
हम्म
the Cl gets knocked out first, तो carbon gets a positive
Okay.
charge, becomes a carbocation. लेकिन होता है कि if the positive charge is at the end of the chain, the positive charge is very large, क्योंकि it's not
हम्म
surrounded by
Okay.
anything, ठीक है, so if it's very
हम्म
large, तो it will not let the Cl go. तो होगा ये कि it is very hard or difficult to form a primary carbocation or a 1 degree carbocation.
हम्म
टर्शी के अंदर carbocations form हो जाते हैं. टर्शी के अंदर what happens is if the Cl gets knocked out, Cl leaves, the carbon gets a positive charge, but that positive charge is very small. Why? Because it's surrounded by electrons, lots of electrons around it, ठीक है, which will neutralize the
हम्म
positive. The positive charge is not going to be strong enough to pull that Cl back. तो इसमें ये होगा कि the carbocation has a lower charge density, which is why it is easier to form. The Cl will easily leave and the carbocation gets formed. So tertiary में carbocations formed are very stable, but in primary the carbocations formed are highly unstable. ठीक है, तो इसलिए a carbocation is not formed to begin with.
Isn't
हम्म
isn't it because in primary you have okay, like major products and minor product, is that it? Because in major product it's more
नहीं,
stable and in minor
नहीं,
product it's less
नहीं,
stable.
it's the same, but that's for alkenes. The
Okay.
the reasoning for major and minor products and alkenes is the same reasoning of SN1 and SN2. It's all about carbocations, ठीक है, तो इसमें ये कि
Okay.
the Br is not going to leave. Why? If it leaves, the positive charge over here is going to be very strong. ठीक है, so it would be very hard for Br.
Right.
हम्म
So what you're going to say is कि in primary 1 degree carbocations, 1 degree or primary carbocations are very unstable due to high charge density, as they have only one electron donating alkyl chain.
So does that mean the higher the charge density is, the more unstable it is?
Then it's not going to form, right? Because if the positive charge is like very, very strong, so why would Br leave? I mean, it would be very impossible for Br to leave. Is that clear?
Okay. Yep.
So the Br is not going to leave unless the nucleophile comes in and knocks it out. ठीक है?
Oh, okay.
So as they have only one electron donating, और टर्शी में होगा कि टर्शी के अंदर, like if you add tertiary, in that case it would be very easy to form a carbocation, because it would be very easy for Br to leave and take the electrons. Why? Because the positive charge that will be formed on the carbocation is not going to be that big, क्योंकि it's surrounded by electrons, ठीक है? So that will neutralize the positive charge. So the Br could easily leave.
ठीक
तो
बोला
और remember इसका भी, और वो जो major minor products are, that's to do with alkenes. They both have the
Yeah.
same. They both have the
सेम
same.
रीजनिंग
ठीक है,
हम्म
और कितना रहेगा इसमें, तो ये सारी कर लेते हैं. Two different halogenoalkanes P and R with the molecular formula C4H9Cl are separately dissolved in ethanol and heated under reflux with NaOH. ठीक है, ethanolic NaOH में क्या होता है? What happens to a halogenoalkane? Ethanolic
I
एलिमिनेशन
think
elimination होती है, ठीक है,
हाँ
मतलब
एलिमिनेशन
मैं वो चार्ट
yeah.
देख.
तो फिर एल्कीन
हाँ, तो concentrated NaOH ethanolic, that will turn it into an,
हाँ एल्कीन बन जाए
it's going to turn it into an alkene. Name the type of reaction that's elimination. Write an equation using,
Elimination.
हाँ, तो equation क्या होगी? C4H9Cl. So elimination would be C4
C4H8
C4.
and the HCl will get eliminated. ठीक है?
HCl.
Draw the skeletal formula of methyl propene. Propene क्या होता है? That's
C3.
3 or
3
methyl.
carbon.
Secondary methyl. So
Yeah.
what's the skeletal formula? That's going to be this.
Yeah, and a line up there. Yeah.
ठीक
And
है.
then वो ऊपर.
अच्छा वो कह रहा है give the name of PNR. उसने क्या कहा था? उसने कहा both of them they form. So the product is methyl propene.
दोनों का molecular formula
So
भी
I
हमारे
think
पास.
हाँ अब मुझे
C4H9.
बताओ कि if HCl leaves, अच्छा if HCl leaves, तो इसका मतलब है this is the position where the where the H and Cl were attached, right?
mhm.
तो या तो आपके पास होगा कि the Cl is attached on the left side,
Yeah, right side.
हाँ, या फिर right side पे, ठीक है? And the
Mhm.
carbon is over here, or you could have okay, the Cl is attached in the middle, and the H is attached on the बाकी सारे H हैं, ठीक है? This is H. This one will have 2 H's, 3 H's there. So those are the only two. Both of them will produce methyl propene. Because when the Cl gets knocked out, so you're going to have a double bond at this point. And if the Cl gets knocked out, you're going to have a double bond at this point. ठीक है? So names बताने हैं. What's the name of the first one? What's the name of the second one?
I think that is 2-methyl something. Which one are we talking about? The one here?
This one.
Okay, yeah. Yeah. 2-methyl.
Longest chain क्या? That's propene, right?
Propene.
Yeah, propane.
And then 2-methyl है.
ठीक है, so you got 2
Yeah.
methyl है.
And 1 chloro.
Yeah.
1 chloro, ठीक है? You order change करना it's alphabetic, so it's 1 chloro 2 methyl propene.
Yeah.
And this one would be not propene.
Propane.
अच्छा
Because it's
this
halogen alkane.
हाँ, plus there's no double bond, ठीक है? So it's an alkene. This one would be propane, and it's going to be methyl is on the second, and the Cl is on the second as well. So that's
the 2-methyl 2-chloro.
हाँ, 2 chloro पहले और फिर 2.
2 chloro 2-methyl.
2-chloro 2-methyl propane.
ठीक है. तो बस ये last से quickly कर लेते हैं. You've got
C2H4. That's alkene.
Same first thing. Name the reagents and conditions reaction 1 to 6 required for. So basically, you have to name all the reagents and conditions. This is an alkene, and it turns into an alcohol. मैं ये chart पे ही कर लेता हूँ. ठीक है? How do you turn an alkene to an alcohol?
Oxidation.
नहीं.
Potassium permanganate. The reagent.
नहीं, it is true. लेकिन there are two ways to turn an alkene into an alcohol. You either hydrate it, water add करो 300 centigrade, 60 atmosphere pressure, phosphoric acid as catalyst, right? Or you can have cold dilute KMNO4. Mild oxidation. अच्छा लेकिन mild oxidation का problem ये है कि diol forms.
Diol forms.
So it's not a diol. It's
hydrolysis.
नहीं, hydration.
Hydration.
You get the water 300 centigrade and 60 atmosphere pressure or phosphoric acid catalyst. ठीक है?
Phosphoric acid.
Next one, alcohol to an aldehyde. वो किसका होता है?
Oxidation.
I think that's oxidation.
That's oxidation. ठीक है, but that's उसको कह दो कि
partial oxidation.
Partial oxidation. ठीक है? किधर गया मेरा revision chart? एक सेकंड, किधर चला गया? बंद कर दिया. आइए. अच्छा, so it's partial oxidation के alcohol to aldehyde. To stop at aldehyde क्या करना है? It's K2Cr2O7 acidify reflux, but you're not going to use reflux. क्योंकि अगर reflux use करोगे तो aldehyde will turn into carboxylic acid. You're going to distill. Clear है? So you're going to heat with distillation. As the next one, aldehyde.
Amine.
Nee, what is this?
Nitrile.
How do you go from aldehyde to? It's not just a nitrile; it's an OH as well.
Reduction is it?
नहीं
लेकिन
aldehyde
रिडक्शन से तो वापस अल्कोहल नहीं आ जाएगा।
हाँ रिडक्शन तो वापस अल्कोहल होगा। अच्छा ये फिर से चार्ट के ऊपर ही ना कि
I think
there's
it's
a-
further oxidation.
नहीं ये साइनो न्यूक्लियोफिलिक एडिशन होता है साइनोहाइड्रिन वाला कि
हाँ
when you
इसका रिएक्शन नहीं
when you
होता।
have an aldehyde so that मैं वो बता देता हूँ what will happen ये ड्रॉ कर लेता हूँ if you have an
Yeah.
aldehyde अच्छा this is H this is CH3 ठीक है carbon is positive so the CN -1 will get attracted to it and the O is going to get repelled so what happens is कि वो जो CH3 CN gets attached at the bottom और जो top पे है ना O-1 gets formed and that O-1 then attaches to H+1 coming from HCN so you get an alcohol as well as a CN attached to the same carbon atom ठीक है तो ये reaction है this is nucleophilic addition you need to know the mechanism of this reaction as well जो यहाँ पे given है ठीक है aldehyde CN gets attached और ऊपर से ना OH gets attached ठीक है so it's HCN and NaCN catalyst those are your conditions अच्छा फिर what happens जब नाइट्राइल को dilute acid के साथ हीट करते हैं what does it turn into
Amine.
नहीं not an amine it's this if you have a CN you heat it with dilute acid it hydrolyzes and turns into a carboxylic acid
Oh yeah.
ठीक है so remember ये chart जो है ना सारा it's basically if you just memorize this chart you'll be able to so the CN will turn into a carboxylic acid just this part तो
Okay.
ये जो last part होगा ना the CH3 you got a COH you got an H और फिर ये end पे ना it's going to turn into a carboxylic acid ठीक है और वो ऊपर भी how do you go from an alcohol to a halogenoalkane
That's substitution
substitution
or chlorination.
हाँ और उसमें alcohol there's a lot of reactions where you can put Cl it's PCl3 plus heat or HCl plus heat or PCl5 तो उन सारों से ना और SSCl2 plus heat all of these will result in a halogenoalkane और फिर the halogenoalkane again you got substitution with the amine ये कौन सा
अमोनिया
हाँ तो that is
Ammonia.
ये वाला अमोनिया एथेनॉलिक प्लस हीट
हम्म
और हीट फ्लक्स ठीक है
heat and pressure
या फिर अमोनिया गैस प्लस हीट इन अ सील ट्यूब ठीक है
ठीक होगा।
तो वो ये पार्ट है अच्छा ये हो गया और ये वो उसका मैकेनिज्म भी दे दिया which I was talking about I told you
Isn't this nucleophilic?
addition
Yeah, addition.
This is carbon positive this is oxygen
Negative.
And
Yeah.
the lone
They
pairs
will
on
attract.
the lone pairs on
Yeah.
CN are going to get attracted to the carbon and oxygen gets repelled right
फिर उधर
Yeah.
अब फिर अगले स्टेप में the oxygen lone pairs are going to get attracted to the H और वो
Yeah.
चला जाएगा ठीक है
Okay.
product of reaction number 3 what are the functional groups
Where is reaction 3?
this one वो वही है it's an alcohol and a nitrile
Nitrile.
and an alcohol ठीक है
Yeah.
और draw the structure we did that ठीक है we did that already चलो ठीक है पूरा पेपर खत्म ठीक है
Okay.
okay then
Sir, I have a question.
yes
About the classes. How many days are they gonna be? Like you said, it's I don't know, like how many
ये
days?
अब 4 days a week ठीक है
4 days a week. And which days?
Monday to Friday between Monday and Friday
Monday to Friday. So like today was really tough for me because I had classes
नहीं आज
from
नहीं
5
आज
to
वो था कि
7.
नहीं वो कर लेते हैं आज वो था कि फर्स्ट डे था रमजान का सो वी गोइंग टू सेट द
हमारा second day.
हाँ नहीं वो टाइम सेट कर लेते हैं ताकि वो
Okay.
11 है तो अगर सारे कंफर्टेबल 11 के साथ सो आई एम गुड विद दैट ठीक है
Yeah, I'm comfortable. I'm
चलो
good.
ठीक है
Okay.
वो
That was.
Allah Hafiz.